हरिः कर्ता।
Now, the fourth and final level of measurement in the level of measurements is the ratio level. Just like the interval scale, the ratio scale is a quantitative level of measurement with equal intervals between each point. What sets the ratio scale apart is that it has a true zero, that is a value of 0 on a ratio scale means that the variable you are measuring is absent. Population is a good example of ratio data. If you have a population count of 0 people, this means there are no people at all. So if you take another example, if you take another definition of a ratio level of measurement is the highest level of quantitative measurement, where data is measured on a scale with equal intervals between values and a true 0 point exists, so indicating the complete absence of the attribute being measured. So this means that the meaningful ratios between the values can be calculated. So what are the implications of a true zero? As the name suggests, having a true zero allows you to calculate ratios of your values. For example, if you have a population of 50 people, you can say that this is the half the size of a country with a population of 100. So you can see some of the examples of ratio data on your screen, such as ratio variables. These are called whichever variable that carries a ratio data. Whichever variable that carries ratio data is known as ratio variables, or if you name a ratio data with a certain variable, that variable is known as a ratio variable. Okay, so ratio variables can be discrete, that is expressed in finite countable units, are continuous, potentially taking on infinite values, finite and infinite. So the following are some of the examples that you can see on the screen. Weight in grams, continuous. Number of employees at a company, again that's a discrete one. And speed in miles per hour, continuous. Length in centimeters, continuous. Age in years, continuous. Income in dollars, continuous. Sales made in 1 month is discrete. Okay, now the question arises, how to analyze a ratio data. So the great thing about data measured on a ratio scale is that you can use almost all statistical tests to analyze it. So how do you analyze a ratio data? Let's take a look. So as usual, we will take a descriptive statistics first. Descriptive statistics for ratio data. So that consists of, you can use the same descriptive statistics to summarize ratio data as you would for interval data, but the only with the addition of coefficient of variance. So we will recap briefly here, but for a full explanation, I would urge you to watch the previous videos which are on categorical, which are on nominal and interval levels of data, ordinal levels of data. So first we'll begin with summary descriptive statistics. So that is frequency distribution. In frequency distribution, So this shows how frequently each value occurs within your data set. This is what is a frequency distribution. So the frequency can be expressed as either a count or a percentage. Then after that we have in descriptive statistics, that is a measure of central tendency. Measure of central tendency consists of mode, median, and mean. So the mode is the value that occurs most frequently in your data set, while the median is the middle value and the mean value is the average of all values within your data set. Okay. Um, so the mode, median, and mean are all measures of central tendency which help you to gauge how your data are distributed. So then the final one we have is measure of variability. So we have range, standard deviation, variance, and coefficient of variance. All shows all show you the variability within your data set. That's what all these parameters, all these variables, all these statistical measures will show you. Range, standard deviation, variance, and coefficient of variance all show you the variability within your data set. Coefficient of variance is unique to ratio data because it's a fraction. So calculated by dividing the standard deviation by the mean that we will be doing. Okay. So these are the descriptive statistics that we can use to analyze a ratio data. Then on a right side we have statistical tests. Statistical tests for analyzing ratio data. As with interval data, you can use both parametric and non-parametric tests to analyze your data. Still, as we know, parametric tests are more powerful and therefore allow you to draw more meaningful conclusions from your analysis. And We will be discussing some of the parametric tests that we can use to analyze the ratio data. Out of them, the first one is t-test. T-test to compare the mean value of two data samples. For example, what is the difference in the average income of 40 to 50 years olds living in London and Leeds? That's T-test. It's for the comparison of samples. Then we have ANOVA test is ANOVA test to compare the mean values across three or more samples of data. For example, what's the difference in the average income of 40 to 50-year-olds living in London, Leeds, and Birmingham? And then we have the next one, that's a Pearson's R. Pearson's R. So Pearson's R to see if there is a correlation between two variables. For example, is there a relationship between Pearson's age and years and their income? And then the final one that you can see on the screen, it's a linear regression. So linear regression, a simple linear regression to model or predict the relationship between two variables. To model or predict the relationship between two variables, so or the impact of one variable on another. For example, can a person's age in years be used to predict their income? So that's what we will do. We'll see whether can a person's age in years be used to predict their income or not. So that's what is our simple regression. So these are all different ways of exploring ratio data.